All right, let's talk about slope-intercept form. So remember, we have more than one form of a line. Here is slope-intercept form. It looks like this. Y equals mx plus b. M is the slope of your line, and b is your y-intercept. Now it's really easy to graph when it's in this form, so that's why it can be fairly useful. So if we're looking at an actual equation, y equals 2/3 x plus 2, our slope for this line would be 2/3. That's really helpful because we can just pick the slope off. Our y-intercept would be at 2. So x and y-intercepts. Y-intercept is the point that it crosses the y-axis. So if it's 2, that we know our line goes through the point right there. We know we have a slope of 2/3, so that we know if we go up 2 and over 3 from that point that's on the line, and we continue to do that, okay, that's the slope of our line. That's why slope-intercept form is helpful. But this is what you'll want to write in your notes. Slope-intercept form looks like this. Y is all by itself equal to mx plus b. Okay, there's a couple of ways to write an equation in slope-intercept form. We're going to build off of what we did before. Okay, we're going to build off of the point-slope form of an equation. There are other ways to do this, but this is one method. Okay, write the equation of a line with slope -2 that passes through the point 1, 4 in slope-intercept form. So what that tells me, slope-intercept form, is that I want my equation to end up looking like y by itself equal to everything else on the other side. How I'm going to start this is the way we started our previous questions. I'm going to start by using point-slope form, okay, which hopefully you remember is y minus y1 equals m times x minus x1. Because although point-slope form and slope-intercept form are two different forms, they still describe the same line. Okay, so we're going to start with point-slope form. We're going to substitute in the values that we know. So we have y, remember the one without numbers just gets to stay a y, minus y1, that means the y from the point they gave us, which in this case was 4, equals m, my slope is 1, times x minus the x from our point, x1. Okay, now we simplify. There's really nothing to simplify here. We just have y minus 4 equals 1 times x minus 1. We do, however, then look up and say, uh-oh, I was supposed to write that in slope-intercept form, and this is point-slope form. So all we're going to do is simplify this equation further so that it looks like y equals mx plus b. To do that, we want to get y completely by itself and get rid of the parentheses. Okay, so here's our next step. We take what we have and we're going to convert it into slope-intercept form by first getting rid of the parentheses using distribution. You distribute that 1 times x is just x, and 1 times -1 is just 1. Okay, we got rid of parentheses, and your next job then is to get y all by itself. Right now it has a -4, so to get rid of that we would add 4. We have to do the same on the other side, and we end up with y equals x plus 3. Now we have our equation of our line in slope-intercept form. So again, we started this using point-slope form just because that's what we are used to using and it was familiar. That's why I chose that method. Okay, we got it in point-slope form, and then all we had to do was get rid of the parentheses and then get y by itself, and it was now in slope-intercept form. Notice it looks the way it's supposed to. Y is all by itself equal to everything else on the other side. Right, here's another example. Write the equation of the line with a slope of 0, so that's my m, that passes through the point 3, 5. We want to write that in slope-intercept form. Okay, so here's my x and my y. So how do we do that? Well, again, we're going to start by using point-slope form. Okay, we substitute the values we know. Y minus the y from our point is 5 equals our slope m is 0. X minus the x from our point was 3. and we simplify that. Well, that's pretty much simplified if we're doing point slope form. If we want slope intercept, so make sure again you have in your notes what slope intercept looks like. It should have y all by itself. So now we need to take our equation we've created and convert it so that it looks like this with y all alone. To do that, first we get rid of our parentheses, so we distribute the 0. If we multiply, 0 times x is 0, 0 times 3 is 0. So on this right hand side we have just 0. Okay, next we need y to be all by itself, so we add 5. We have to do the same on the other side, and we end up with just y equals 5. Now that will happen only if your slope is 0. If your slope is anything other than that, you should have an x in your equation, but if your slope is 0, your x completely disappears.